Good evening, everyone. My name is Rohith Reddy. I am from NIT Andhra Pradesh. Today, I am discussing about the structural methods in which I am specifically discussing about the string matching. Now, we will be learning about the recognition of boundary shapes. It can be done in two ways. The first method is matching shape numbers and second method is string matching. And in this particular video, we will be learning about the string matching. Actually, the representation of structural pattern is done through strings. String matching is a method which helps us to know to how much extent two images are similar with the help of their boundary shapes. For a image, boundary shapes are represented using strings. So if we consider two images A and B, let us assume the string which represent the image AB, A1, A2, A3 and so on AN. And the string which represent image B is B1, B2, B3 and so on Bn. So if we consider position K or some positions in which there is a similarity in the characters of the both strings, so the number of similar characters is known as alpha. We represent it by using alpha, and the symbols which don't match is represented by beta. So mathematically, beta can be represented as the difference between maximum of the length of string A, comma string B minus alpha, where alpha is the number of characters which are matched in string A and string B. So if we consider a case in which both the strings of A and B match perfectly, then we can tell that beta is equal to 0. Now we will be discussing about the similarity of both images. So similarity can be represented as the ratio of number of symbols matching in both strings divided by the number of symbols which are different in the both strings. So if we substitute beta from the equation 1, which is the difference between the maximum of length a comma length b minus alpha, in the equation 2 we will be getting r equal to alpha by maximum of mod a comma mod b minus alpha. So if we consider two different uh, two different strings which are perfectly matched, so what happens here is maximum of mod a comma mod b minus alpha will be 0, which implies that r equal to infinity. So it tells that the similarity is infinite, which means they are perfectly matched. From this we can tell that when two images are perfectly matched, then r equal to r will be infinity. Now we will be discussing this in more detail with the help of the following images. Here if we observe, we have 7 images where A and B represent the boundary images of two different objects. C and D represent the approximate polygon boundaries of the corresponding objects A and B, and E, F and G represent the similarity tables which we will be discussing later. Here matching is done character by character. The beginning point on each boundary is important in terms of reducing the amount of computation. So strings were formed from the polygon by computing the interior angle theta between segments as each polygon was traversed clockwise. So in this current images, we have considered the symbol 8 symbols with an increment of 45 degrees in the angle. So the first symbol lies in between 0 to 45 degrees, second symbol lies in between 45 to 90 degrees, third symbol lies between 90 to 135 degrees and so on, and eighth symbol lies between 315 to 360 degrees. Here if we see the images E, F and G, here image E represents the results of the computation of similarity of 6 samples from object 1 with itself. So if we observe 1.1 and 1.2, if we consider these both samples, we know that 1.1, 1.a and 1.a are same. So they will have a similarity of infinity, as I have discussed earlier. If two different strings perfectly match, then the similarity will be infinity. So we can see here it is as it is true. And here a string table F also represents the similarity table between itself. between 2.a 2.b and 2.a 2.b and so on 2.f. And but here if we observe table G, here what happens is uh, it is telling us about the similarity between the image 1 and the image 2. So if we consider the table G, it has very less R values with respect to uh, the image table E and table F, since we are matching the uh, string of two different images at two different positions. So if we observe at any position, the value of R will be less with respect to its original corresponding self matching. So all the R values are considered smaller than any entry in the two preceding tabulations, indicating that R measure achieved a high degree of discrimination between the two classes of objects. Here, for example, let us assume we don't know about 1.a string, whether that it belongs to class A, that is image A or image B. But from these tables, we can predict about that to which image it belongs. So if we consider table E, if we consider and in that if we consider column 1.a, the smallest value available is 4.7, and if we that is it is the similarity between the lowest similarity of 1.a and 1.f, which is represented as 4.7. But if we consider table G, if we match it with the second image, then it is showing that the largest value possible in this table is 1.24, which is even less than the smallest value of the table E. So from this we can conclude that the similarity is more in case of 1.f table E. That is when we compare 1.8 1.f instead of when we compare 1.8 2.a. From this we can say that the 1.a string belongs to the class object 1. So in this video, we have learned about how to match two different strings and how to know whether a string belongs to image A or image B by using the string matching. Thank you.